Today we're going to introduce dividing fractions using both bar modeling and also the reciprocal method. So this comes from chapter 3, and again our initial goal will be to get students to model and understand why this division of fractions turns out the way it does. Secondly, we want to make sure that students are able to move to a more abstract approach and apply the rules of reciprocal multiplication. I'm fighting here with my pen, so I'm sorry that I'm being videotaped right now, but let's see if I can fix that really quickly so we can move on. All right, so here's our first problem. It says, let's use bar modeling to solve. We have 3 divided by 1/2. What I'd like you to think of is we're starting with 3 whole bars. So I'm going to draw 3 whole bars here, and I'm going to see what we can do with those to show this division. Notice we're taking this 3 wholes, which I've drawn, 3 whole bars. I try to make them about the same size, and I want to split them into halves. Well, that denominator is really crucial. It tells me how many parts. So this tells me how to split the bar, okay? So we're going to split the bar into halves in this case. So here we go. I have some halves happening here. Well, next it tells me this numerator indicates I want to make 1/2 as a group, or just a group of 1. So this is my group size. So group size, I only want 1 of those. So in this case, I could shade and say, okay, I was able to get 1 group. Maybe I X the next one just to show a different pattern, and there's my second group of 1/2. I could go back to shading and show you a 3rd group of 1/2, and maybe X the next one would show me a 4th group of 1/2. Shade the next one that's available. That can make my 5th group of 1/2. And it looks like I have 1 left here, so I could show you. It looks like I can make 6 halves. This is kind of like having 3 whole candy bars, and I want to split them into halves to see how many friends could get half a candy bar. Well, the correct answer here, 3 divided by 1/2, actually ends up equaling 6. I get 6 whole groups. So you might think of how many groups you were able to make. 6 is the answer. I want to take a look at another one that's kind of similar, because I want you to start noticing maybe a pattern. So for this one, we're starting with 2. We have 2 whole bars. So again, thinking maybe candy bars. Sometimes people like to think of pizzas, but I definitely prefer this bar model method. It's better, I think, to show our parts as equal sizes when we're in a bar format instead of circles or pie models. Now this denominator is different. This tells me I want to make thirds. So 3 parts per bar. So taking our first bar, I have to show thirds. So 2 lines will do that. I have 1, 2, 3 parts. And this next bar needs to be split into thirds also. So I again have 1, 2, 3 parts, 3 thirds. This looks pretty good. Remember that numerator? What's it telling us to do? Oh, that's right. It's my group size. So I want to take a quick minute here and group these into 1s. 1 makes a group. So I could kind of go, oh, here's 1. This makes my first group. Here's 1. That makes my second group. Here's another, makes my 3rd group. Another makes my 4th group. I have another 3rd to make a 5th group of thirds of a 3rd, and a 6th group of 1/3 happening here. Interesting. Looks like I got the same great answer. 2 divided by 1/3 equals 6. I also kind of want you to start noticing something. If you look at this problem, how else could we have gotten this 6? Look at the 2 and the 3 happening in this problem. Interesting, huh? I ended up with a result of 6. Let's go back a minute. Oh, I had a 3 and a 2 in this problem also. I ended up with a result of 6. Interesting. I had a different number of whole bars to start, but when I ended up splitting them, I ended up with the same result. It's interesting. Hopefully you're starting to see maybe a pattern and thinking about that. Well, things do get more complex. For instance, I might give you more wholes to start with. So we have 4 whole bars. Well, we can draw that pretty quickly. 4 whole candy bars. Again, we're trying to keep them the same size. I'm sure there's a better way to do that, kind of like copy and paste, but we'll call this good for right now. So I'm using a model approach, a pictorial approach with bar models. I want to then pay attention to this denominator first. Well, this tells me 3 parts per bar. In each bar, I have to show you 3 equal parts. Oh, just like last time, we have thirds happening again. So I know I can accomplish that by putting 2 lines in each bar. That makes 1, 2, 3 thirds. 1, 2, 3 thirds. And again, I have 4 whole bars to start. Well, take a look. We ignore that numerator until the last step, and here the numerator tells me to make groups. Uh-oh, my pen doesn't want to work. Groups of 2. So 2 go in each group. This is different than before. So here I want to take, maybe shade the first 2, and I'll get my first group. I could maybe X, to show a different pattern here to make another group of 2/3. Well, I need 2 more thirds to make another group. There I get 3 groups of 2/3. I take 2 more of those thirds. That gets me another group of 2/3. That's 4 groups so far. I go again. I have 2 more pieces I can put together. It doesn't matter that it came from one candy bar and the next. Everybody seems to be getting 2/3 here. That seems fair. That's my 5th group. And if you take a look, I can go one more time. I have 2/3 sitting right here. Looks like I'm going to get 6 whole groups. I very unintentionally tried to come up with some random numbers here, and we seem to be getting the same great answers. Will you always get 6? Absolutely not. But looks like in this case today, we got 6 as a result. We could form 6 whole groups. 6 whole friends could share those candy bars, and they each would receive 2/3. Okay, things are going pretty well here. And this one's a little bit harder to see where that 6 came from, maybe. Interesting. Well, let's try another one, and I hope this one doesn't turn out as nicely. I hope we don't even get an answer of 6. Let's see what happens. How many whole bars are we starting with? Well, it says start with 2 whole bars. Let's do that. Quick sketch of 2 whole bars. Now, my denominator is different. This is good news for me. Makes me think a little bit. I want to split these into fifths. So I know I need 4 lines. 4 lines make fifths. I tried to make them kind of equal. I see I got a little bit generous on a few of these, but we'll call that pretty close. I think it'll be able to accomplish the same goal here. Well, remember the numerator comes next. So that 5 was 5 parts per bar. And this numerator, it's a 3. That means 3 per group. I'm grouping these into 3s this time. So this time I'll shade 3 of them. 1, 2, 3. And I end up getting 1 whole group. 1 group of 3/5. I'll go again. This time I'll try some polka dots just because I feel like trying a different pattern to show you it's really okay to use your own strategy. I just think it's important to separate your groups here. So here's another group of 3/5. Let's go again. Shade 1, 2, 3 parts. That makes another group of 3/5. I have 3 groups so far. And now you notice there's a problem. I'd love to put a polka dot here, polka dot, but I just can't. Meaning I have 1 extra. This is interesting. I have 1 extra. If you dig into our Math and Focus textbook, it's really going to show you the strategy of maybe adding on. So they're going to show you this idea of a dotted line. How many did we really hope to have in this group? Well, that numerator said I wanted 3 in a group. So it's kind of like saying, oh, I'm missing these 2 pieces. Interesting. I have 1 extra, but how many were needed? In that group, I was trying to make 3 that were needed. Wow, I still get a great answer here. If you notice, it's a mixed number this time. I have 3 whole groups, but some extra happened also. So it looks like 2 divided by, oops, that's not good. 2 divided by 3/5 got me 3 whole groups and 1/3 more. Oh, sometimes we'll get some leftover pieces, and that ends up looking like a mixed number, or the fractional piece of our mixed number. Interesting. Oh, and then sometimes we don't even start with a whole number. This one gets really complex because they tell me to start with 3/8. So I'm going to make my bar pretty big so I can show these 8ths to you. And that means I first need to start with 8ths. I often start with 4ths and split those again. So I know I have 8 parts. But I don't have the whole bar this time. I have 3 of the 8. So I'm going to try to shade 3/8 for you. Meaning this is how much I have to start with. Well, they want me to split this into 4ths. And that's going to be kind of difficult to show in the same bar. So I'm going to try what's called a comparison bar model for you. So this is another strategy that is possible to look at. We are not going to emphasize this a whole lot in the classroom, but some of you are higher level thinkers and you're up for the challenge, so you could possibly see this. Meaning, I only want 4ths in this bar, right? This denominator tells me 4ths. Well, that means every 2 of these, every 2 of those, every 2 of those. And my thinking here is kind of like 2/8 is the same as 1/4. I know that because if I took 1/4 times 2/2, I would definitely get 2/8 an equivalent fraction. So I'm kind of picturing that. I'm kind of dropping this line down, aren't I? I hope you can see that in this comparison model. Oops, and I guess this line is the final. Now, remember, I want a group of 1/4. The numerator tells me I just want 1 of those to make a group. Oh, I noticed something. This whole 4th is the same as 2 of those 8ths. So sitting right here, kind of combined, if you will, I can compare and say, oh, that much would get me one whole group. These 2/8 would make one whole group. It's the same size as a fourth, isn't it? But then if you look, I really want to box in another. I want to say, okay, well, do that again. 2/8 is equal to 1/4, but we have a problem. I notice right here, I don't have 2/8 to circle or group. I only have one of them. I have one extra part. And how many were needed? Be careful. Even though it looks like I'm trying to make these fourths here, right? I'm trying to make fourths. These were cut into 4 down here. It says that I need 2 of them. I need 2 of them to make a group. So there were actually 2 needed. Oh, interesting. 3/8 divided by 1/4. In fact, got me one whole group, which makes sense because 3/4 is bigger than 1/4. Or sorry, 3/8 is larger than 1/4. And I had some leftovers, 1/2 left over. Oh, mixed number again. That could happen. Again, these bar models are definitely challenging. It's hard to see why this division of fractions happens the way it does. So this problem, it's a challenge. I would not expect all students to be at this level. Now, do I want you all to understand this idea before now with whole numbers being divided? Absolutely. I think that's something that we all can tackle and work towards. Well, once we get this idea of how complex these can be, and the models definitely with this comparison bar model can be challenging, we might need another strategy. Here's another one. It shows me 7/10 divided by 1/2. They tell me to try a bar model again, so I will try a speedy quick bar model with you, and we'll try the same idea just to see, for those of you who are ready for this challenge, what you think, if you're able to handle this idea. So notice I'm trying to make tenths here. So I'm splitting the 2 sides into 5, 5 and 5, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks pretty good, but I don't have the whole bar. I only have 7/10 of it. So I can only shade in 7 of these. So let's quickly try to shade 7 of these to show I have 7/10 of the bar. Well, I'm going to try this good old method again, this comparison bar model. So my next bar for comparison is supposed to be 1/2. Now I'm trying to make my bar the same length. It's like the candy bar is the same kind, and it's the same length, of course, but it's only half as long. So let me think for a minute. Tenths. This is split into tenths. How many tenths would it take to make half of this bar? Well, I hope you're thinking to yourself, I could turn that into tenths somehow. What would it take? Oh, multiply by 5 on the top and the bottom. Looks like it take 5/10. So I kind of want to find that 5/10 line. 1/10, 2/10, 3/10, 4/10, 5/10. I want to bring that down. Ah, there's the halfway mark. I can be pretty accurate if I can find this idea of an equivalent fraction. This is just thinking off to the side that I'm showing you here. Well, I have 1/2 that I'm trying to group. Oh, I can try the same strategy as last time. I could try this boxing in method, right? I know that 1/2 is the same as these 5/10. Awesome. I can compare and say, I get one whole group. There it is. And I want to do that again. Oh, good. Let's grab the next 5/10 and say it's equal to 1/2. Oh, but you can't. Because if you notice, I only have 2 of those tenths left. Oh, this is super helpful. I noticed something. 2 extra parts. And I just have to remember what size the group was. How many was I trying to put in the group this time? Well, remember it took 1, 2, 3, 4, 5 of them. There were 5 needed. Just like in the first one, I had 5. That made one whole group. So 5 were needed. That becomes my denominator. Well, how would we write this final answer? 7/10 being divided by 1/2 seems to get me one whole group. Don't forget, we did get one whole group up here. And 2/5 more. Final answer. Oh, there's got to be a better method than this. This sure is challenging, and it's hard to see where that 1 and 2/5 comes from when you look at all of these numbers, 7, 10, 1, and 2. Well, good. There's another strategy. This is called the reciprocal approach. So we're going to multiply by the reciprocal. Now, students don't like that R word a whole lot. It's pretty challenging to remember, so say it 5 times. Reciprocal, 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 reciprocal. You get it. But sometimes students have learned to call this freeze, change, flip. So if you need a shortcut, another way of thinking of this, freeze, change, flip might be the way to go. So what we want to do is take this, and instead of modeling this time, we want to turn this 6 into a fraction. Well, I hope you remember that all whole numbers could be written over 1. That's the same as 6 whole, right? 6 whole candy bars or 6 whole pizzas or whatever they may be. And I still want to write down I'm dividing by 2/5. That's a true statement. But there's a faster way to get there, right? Once we try this and we could do the model with it, we could also prove it using this strategy. We use something called freeze, change, flip. Or we multiply by the reciprocal. So let's take the first fraction now that we have, 6/1, an improper fraction, but we can roll with that. And we freeze it. We keep it the same, 6/1. It does not change. But then we want to multiply by the reciprocal. So I'm going to change from division to multiplication. Notice I don't use an x. I say x for algebra. Next it talks about a flip, or the reciprocal. So the reciprocal of 2/5 means that these two numbers switch positions. The 5 becomes my numerator, and the 2 moves to the denominator. Oh, I know how to multiply fractions. I can multiply straight across. But if you also remember, sometimes the numbers get kind of large when I do that, so you might want to look for some cross simplification. Oh yeah, 6 and 2, they share a common factor of 2. Let's divide both of these by 2 and see what we get. 6 divides by 2 3 times, and 2 goes into 2 one whole time. Notice I'm trying to keep these new factors on the outside of my cross simplification so that I can grab the right information. Some students like to do a rewrite step at this point. They'll call this 3/1 times 5/1. And if you notice, we can actually multiply across now. No more cross simplifying to do. 3 times 5 is, in fact, 15, and 1 times 1 is 1. Oh, this is the same as 15. Now, I'll be honest with you. This is a good answer, but if it's hard for you to see, you could definitely go back and draw yourself your 6 whole bars real quickly, and you could split them into those 5 equal parts. You could group them into 2s, 2 in each group, and you get the same great answer. That's true, it would work. 15. Multiply by the reciprocal. Funny words for a freeze, change, flip. Let's try another one, and I have to be honest with you, I probably would not want to model 9/11 and 3/4 or when the numbers get too crazy or big. So instead, we try the freeze, change, flip, FCF. Or, on a test, you're going to hear multiply by the reciprocal, fancy words. So what gets frozen? Burr, the 9/11, it stays the same. But if you get outside and you freeze, you notice you have to change. You have to change from division to multiplication. And you're so excited that you can now go back outside and not be frozen, that you go outside and you do a quick flip. So this 3/4 is going to flip to its reciprocal of 4/3, meaning the numerator and denominator switch positions. Some students like to draw this little arrow like, hey, I'm going to flip this guy. Okay. Is there any cross simplifying that we can show this time? 11 and 4, not many common factors. The 11's prime. And 2 doesn't go into 11. 9 and 3, we can cross simplify here again. And if you notice, 9 and 3 both share a common factor of 3, their greatest common factor. Well, 3 goes into 9 3 times, and 3 goes into 3 one time. Let's try that idea of a rewrite step. So I have 3/11 times, remember we're multiplying at this point, 4/1, because we're using the reciprocal method, reciprocal multiplication. Now if I multiply across, I'll get 3 times 4, which is 12, and 11 times 1, which is, in fact, 11. And I'd love to circle it and say, ta-da! But if you notice something, this is called improper error. So we need a way to get there. We need a way to show this as a mixed number. Well, if I could picture and visualize in your head, if you can, you have 12 11ths, you have more than one whole pizza. You have more than one whole candy bar. In fact, 11 goes into 12 one whole time. 1 is your whole number. And you just used up 11 little pieces. So how many would be left? Oh, just 1 out of the 11 I'm looking for. 1 and 1/11. Now I really did this abstractly. I did this in my head. Some students are not ready for that move, so this might be another way to go. You could definitely take your numerator and divide by your denominator. Well, 11 doesn't go into 1. I'll put a 0 there. But it does go into 12 one time. 1 times 11 is 11, and when you subtract, you're left with 1. Oh, I'm getting similar numbers. If you start at your quotient, which is up here at the top, it's always above your division problem. And you go around what I call the ring of fire because it sounds dangerous and exciting, and it will get you a mixed number in no time at all. It looks like I get 1 as my whole number. That's where this 1 comes from. And this 1 is what I tackle next. I go around the ring clockwise, and I notice there's a 1 which becomes my numerator. That's where that 1 comes from. And the last thing, I keep the denominator. It was 11ths, it still is. 1 and 1/11. You could definitely try modeling that. I think it probably is possible, just might be a little bit challenging. But this freeze change flip approach, oh, it's fast and it works every time. With that, I definitely hope that you have learned how to use multiplication with the reciprocal to get rid of these divisions and treat them like multiplications. I also hope that you have some understanding of how to divide fractions using this model approach. So our goal today was to get you that modeling method started and then to move you into that reciprocal approach.